At some point, we have all held a glass of water or wine. Others have admired the crystal-clear transparency that allows you to see right through it. But, have you ever wondered how something as delicate and pure as glass is crafted? The result will not be what you expect. Therefore, in this video, we will give a brief history of glass and the behind-the-scenes of glass manufacturing plants. Glass has a rich history dating back over 4,000 years. Ancient Egyptians and Mesopotamians first discovered glass by accident, likely when sand mixed with ash and was exposed to high heat in a furnace. Early glass objects were small and mainly decorative. By the 1st century AD, the Romans revolutionized glassmaking with the invention of glassblowing, making glass more accessible. Over centuries, glass evolved from luxury items to essential materials in architecture, art, and everyday use. Manufacturing processed well, the process of making glass is a fascinating blend of art and science that begins with something as simple as sand, where ordinary materials are transformed into extraordinary creations. The story of glass begins with raw materials, the most important of which is silica sand. Silica, a natural compound found in quartz, sandstone, and other materials, is the key ingredient in glass production. But sand alone isn't enough to create glass. To achieve the right balance, other materials like soda ash in the form of sodium carbonate and limestone in the form of calcium carbonate are added to the mix. Each of these components plays a critical role in determining the final properties of the glass. For instance, soda ash lowers the melting point of silica, making the manufacturing process more energy efficient. Limestone, on the other hand, acts as a stabilizer, preventing the glass from dissolving in water. These ingredients are carefully measured and mixed to create the perfect batch, known in the industry as the glass batch. Once the raw materials are ready, the next step in the journey takes place in a massive furnace, often referred to as the heart of the glass manufacturing plant. These furnaces are engineering marvels, capable of reaching temperatures as high as 1,700 degrees Celsius is equivalent to 3,000 degrees Fahrenheit. The glass batch is loaded into the furnace, where it gradually melts into a molten state, resembling a thick, syrupy liquid. As the mixture heats up, the silica undergoes a transformation, fusing with the soda ash and limestone to form a new substance called molten glass. This stage is crucial because the quality of the final product depends on how well the materials are melted and mixed. Any impurities or inconsistencies in the batch can lead to defects in the glass, making it unsuitable for use. With the glass now in its molten state, it's time to shape it into the desired form. This is where the artistry of glassmaking truly shines. There are several methods used to form glass, each with its unique applications and techniques. 1. Float glass process. One of the most common methods is the float glass process, which is used to produce flat glass, like the kind found in windows and mirrors. In this process, the molten glass is carefully poured onto a bed of molten tin. Because glass is less dense than tin, it floats on top, spreading out into a smooth, flat sheet. The glass is then slowly cooled and solidified, creating a flawless, uniform product. Blow and blow process. For creating glass bottles and jars, the blow and blow process is employed. This technique involves blowing air into a molten glass gob, a small, measured portion of glass, to create a hollow shape. The gob is first blown into a rough shape, called a parison, and then transferred to a final mold, where it is blown again to achieve the desired form. Press and blow process. Another method, known as the press and blow process, is used to make containers with wide mouths, like jars. In this technique, the molten glass is pressed into a rough shape before being blown into its final form. This method allows for greater control over the thickness of the glass, ensuring consistency and durability. Annealing. The strengthening process after the glass is shaped, it goes through a crucial stage known as annealing. During this process, the glass is slowly cooled in a controlled environment, called an annealing layer. The purpose of annealing is to relieve any internal stresses that may have developed during the forming process. Without proper annealing, glass would be brittle and prone to cracking or breaking. The annealing process can take several hours, depending on the thickness and type of glass being produced. By the time the glass exits the layer, it is much stronger and more resilient, ready to withstand the rigors of everyday use. Quality control is an integral part of glass manufacturing. Every piece of glass undergoes rigorous inspection to ensure it meets the highest standards of clarity, strength, and uniformity. Any defects, such as bubbles, cracks, or uneven surfaces, are identified and removed from the production line. Advanced technology, including automated cameras and sensors, is often used to detect even the smallest imperfections. Skilled technicians also play a vital role, using their expertise to assess the quality of the glass and make any necessary adjustments to the manufacturing process. Once the glass has passed all quality checks, it is ready to be packaged and shipped to customers around the world. The next time you hold a piece of glass, take a moment to appreciate the incredible journey it has undergone to reach you.